emphasis on computer science fundamentals. Um, and yeah.
And I'll turn it
All
over.
right, great. um, thanks. So thank you, Will, for organizing this. Thanks for having me. As he said, my name is Ben Wilhelm. I am a software developer. I am an instructor, as he said, at Full Stack Academy. And I have a consultancy called Nimble Moose, where I help small or newly formed software teams navigate the sort of transition from ragtag group of coders to efficient, cohesive unit by helping them put strategies and processes in place to build institutional cohesion. But one of the things that I help teams improve on is a process for tackling ambitious projects, right? So we've all been up against ambitious projects where you're at the edges of your capabilities. And usually, we as human beings react in one of two ways. If you're super excited, if you're not excited about the outcomes, the potential for your project, you tend to push back, right? You're not really super excited. You're going to, a lot of, is this necessary? This isn't possible. Teams are going to start to kind of unravel a little bit and push back against the requirements of a project. However, if you are excited about the potential for a project, you dive in what I call the tally-ho mentality, right? You spend every waking hour on a project. You are willingly losing sleep over it. You're thinking about it in the shower. Every possible moment you have, you are devoting to a project. Both of these are totally natural responses. Neither of them is sustainable or productive over the long term. Constantly pushing back erodes trust in a team and starts to undermine the project on the whole. The trust that you build within a team, within a group of engineers, or really a team in general, is what allows the team to reach beyond what it thinks it is capable of. When your team is trusting of their teammates, they are more ambitious. Each individual is more ambitious. So tally-ho can be just as problematic, right? It'll burn you out eventually. If you are spending every waking hour thinking about a project, if you are willingly losing sleep over it, eventually you're going to burn out, and you're going to lose that excitement. That excitement that dove you into the tally-ho mentality will be fleeting, and you'll probably end up back in the pushback, right? So there's this great book called The War of Art, where the author, Stephen Pressfield, he's best known for The Legend of Bagger Vance. He wrote this long treatise on creativity, and in a significant portion of it, he goes into the difference between an amateur and a professional. And he points out the very Latin root of amateur says that this is a person who does it for love, a person who personally identifies with the craft that they are practicing, and invests everything they have in it. Whereas a professional keeps some personal distance, right? They reserve some of themselves for the rest of their lives, for other aspects, for their family, for sleep, and so forth. So, pushback and tally-ho both fly in the face of professionalism. If we are going to be professionals, and I'm speaking here to a bunch of engineers, but the process that I'm about to lay out for you is a process for addressing ambitious projects in any discipline. It doesn't have to be engineering. So if you're hoping for hardcore engineering, you're going to be disappointed. I'll set that expectation right now. But these are the result, pushback and tally-ho, are the result of becoming too personally invested in your work, where you are either so afraid of failure that you won't attempt something ambitious, or you burn out on the project and you don't ever want to think about it ever again, right? So what we need is something in between these two extremes. Professionalism sits somewhere between no, it can't be done, and my whole life is this project. As professionals, we have to do this work every day, and we have to stay motivated. And so to stay motivated, we have to break our work into manageable pieces where we can gauge progress. So this is a quote from Seth Godin. He's a massively successful entrepreneur of the last 40 years across a few different industries and disciplines. Most notably, marketing, at least lately. But what I love about it is that if you're too convinced of your own genius, this is going to help keep you humble. It says, if there are no wholly original thinkers, it is impossible to bring a wholly original thought to the world and have the world do anything at all with it. On a good day, 90% of the work that I'm doing is about copying the work of someone that went before me and twisting it just a little bit to make it more useful. Massive amounts of work have been done before you that are applicable to whatever project you are going to take on. Unique products, unique outcomes don't mean unique problems. What follows here is a process for identifying and leveraging the work of others to most effectively amplify that 1% of original work that you're going to put into your specific project. So complex problems can be decomposed into smaller steps in an infinite number of ways. Every complex problem has to be decomposed, or you have no way of gauging progress, right? But the way you define your subproblems is going to be the difference between spinning your wheels or flying down the track. So when decomposing a problem, the first thing to consider when you break things down into smaller subproblems is solved versus unsolved. This feels fairly intuitive, right? But what I want you to remember is that solved problems don't deserve your mental energy right now. So when you break down your larger problem into smaller problems, you're going to divide them first into solved and unsolved, where solved doesn't mean all the work has been done. Solved means you understand what needs to be done between here and there. So a good example of a solved problem is I have a dirty car. I do. You can go out, you can look at it. My car is very dirty. Getting my car cleaned is a solved problem. There's a few different ways I could do it. I can get a bucket and a hose and wash it. I can take it to the car wash. There might be some minor things to be figured out at the car wash. Maybe I'm going to an unfamiliar car wash. I don't know the interface for choosing which wash I want to use, but I'll figure it out. I'm not worried about the complexity of getting my car washed. I'm pretty sure I know what's going to go into it. It just needs to be executed on. So you identify your solved problems. You push them to the end of your list. You don't think about them. Then what you're left with is a list of unsolved problems. And here is where you need to put your effort into framing and reframing these problems. A set of unsolved problems is highly contextual, right? So if you can change your perspective and change your context for any set of unsolved problems, you can reconfigure a whole new set of unsolved problems that add up to the same end product. And what you want to do is reconfigure these problems till you find one that clusters your payoff, where the solution of this one subproblem has an outsized effect on the end product as a whole. Nice idea, right? So how are we going to do that? We're going to seek out patterns, we're going to seek out precedent, and we're going to seek out people. And I want you to notice there's no order to this list. You can do this in any order you want. You can repeat, you can go back, you can do patterns, then precedent, then patterns, then precedent, then people, then precedent, then patterns, then people. However you got to do it, this is a set of tools to be used as relevance dictates, right? But generally speaking, you're looking for commonalities in your unsolved problems in order that the solutions to one problem can be applied across many. So that is, in fact, patterns. That's the first one we're looking at. Where can solutions to one problem apply to others? Which problems look alike? Precedent, I just want to remind you that you're not a special snowflake, right? Someone has done this work before you. Where and when has it been done? Have they developed any tools that are going to make your job easier, that are going to get you from here to there without you having to invest the time in research and development? And then people, as I said, someone's done this before you. And better than reading about what they've done is actually talking to them and finding out what they've done, finding out about the challenges they've faced. They have probably worked in a different context than you're working, but somehow their work overlaps with the subproblem that you are trying to solve. find them, talk to them. So, talk is cheap. I'm sure you want to see an example. In 2015, I worked with the House Theater of Chicago to build a large, ambitious puzzle room called The Last Defender. It was software-driven. The House Theater of Chicago is known for bombastic, design-heavy theatrical productions. This was going to be no different. It drew heavily from the aesthetic of 1980s video arcades. The game itself, the premise, was something of a mashup between the movies War Games and Dr. Strangelove, if you've seen any of those movies. The players would be interacting with, I believe at final count, we had 8 custom-built hardware-software interfaces. So video game cabinets and evil AI with cable patch bay that players are solving puzzles and interfacing in ways that they have to figure out, and then internally we have to keep track of the game as it is played. So what was going to make this different from the House's normal productions is that it's not a scripted performance, right? The House Theater normally builds productions that go from beginning to end, and they do it again the next night. This is going to be a live-action game played by attendees in real time in a non-deterministic way. So these are actual shots of the game itself. It, as I said, contained several stations that were fashioned after 1980s arcade games. The evil supercomputer is there on the bottom right. Players would solve puzzles and input the answers to the puzzles by plugging in patch cables and pressing a button, essentially, to see if they'd done it correctly. There was an ID card scanner. There's a self-destruct option where if at the end of the game, if you have not yet saved the world, you have the option to self-destruct and save at least the world. But everyone has to agree, so there's an interface where everyone inserts their ID cards and says that they're ready for self-destruct. All of this is integrated with traditional theatrical control consoles, so lighting, sound, video. We are shaping and reshaping the room based on the events that are happening in real time. So the main problem here is a collision of paradigms, right? We have an incredibly talented theatrical design and production staff. We have one software developer. This design and production staff could bring pretty much any imaginative whim to reality, but they were used to building these linear controlled experiences, right? The shows that the House produces are interactive in that they acknowledge the audience around them and how the audience reacts, but they are not determined by the audience. They progress according to the script night after night, and they are practiced to do so. So this experience would be highly interactive, as I said, interfaces all over the room for players to interact with, crew-facing software interfaces that are going to be used to tweak on the fly some settings on the game, and then, as I said, integration with theatrical control, lighting, sound, video. This would be non-linear. Our execution, our stage crew is used to, as I said, executing in a linear fashion. This was going to be anything but. And most importantly, this is going to be intolerant, highly intolerant of our usual theatrical fakery. So normally, when you have something on stage that can that needs to appear to be causally related, you can fake it. You can rely on rehearsal and actor cueing and actors giving you cues that they're about to do something. For instance, when the telekinetic cheerleader summons power from the universe to defend herself from oncoming attackers, she can trigger lights, sound, video all around her. But we can rehearse that. But here they have to, anything that happens in the room has to actually be causally related, right? As engineers, this is not something that this is not intimidating to you. But as a theatrical production, this was horrifying to the crew that I was coming into, right? This is a candid photo of our stage manager during a production meeting, where he thought that he was going to have to manually keep track of the actions of 16 players in a room and trigger lighting, sound, video based on what was going on. So this was a quote from the website referring to what you should wear when you come to play the game. But I like it because it reminds us not to panic, not to neglect the obvious, right? So as we dig in, let's start with our solved problems. Lighting, video, sound, coordination between them. This team knows about theater production. These are solved problems. We don't even have to think about these. We have a highly skilled production staff. So instead, we're going to start with the requirements of our game itself, right? This is where we do not have as much experience. This is where we personally lack precedent. And so we're going to just list out, as our unsolved problems, a list of requirements. So for instance, we need to detect coins inserted into the arcade cabinets. We need to detect correct disarm coordinates from the patch bay of the supercomputer. We need to detect key cards for the self-destruct sequence. And all of these need to all of the devices need to also react to cues that may be input into our control consoles, our traditional control consoles, and react accordingly. So there are clearly more requirements than just these three, truncated for brevity. But our first pass, of course, is going to look at our requirements and look for some patterns. So clearly, all of these are looking for, are triggering some theatrical element around, right? We're triggering video, we're queuing lights, video, sound, lights, video, sound. You find if you just start writing out your requirements, you start to see the patterns that emerge, right? So lots of things happening around the room have to cue theatrical consoles. We can pull that out into a single requirement. We have to queue theatrical consoles based on game events. Additionally, we notice that the last one here is the inverse of our theatrical console, of this requirement that we've just defined. So we can lump that all together, meaning we will get all the devices to talk to each other. This is our core problem. This is what's going to make tomorrow better. If we can come up with a cohesive system for inter-process communication, then many of our other tasks are drastically reduced in complexity. So now we recurse, right? We have this problem. We need to start decomposing it into its smaller sub-problems. So again, we'll start with precedent. What do we know? What's been done for us? Theatrical consoles, as we've already identified, there's already precedent for them to talk to each other. They can communicate by MIDI. It is an old protocol, but it is a reliable one. They've been doing it for decades. Theatrical consoles, they communicate by a MIDI line. Our Raspberry Pis, which are what are running all of our software within the room, can communicate via WebSockets. Just run a router to the room, run Ethernet to every station, and set up web servers in all of them. So now we have two precedents and a pattern that both of these are bidirectional serial messaging protocols, right? So now we have our solved problems of our controllers talking to each other, our Raspberry Pis talking to each other, and our unsolved problem is simply now, how do we translate between these two protocols? No longer are we worried about the complexity of getting all of these devices to talk to each other. We just have to figure out how to translate a message from one protocol into the other and vice versa. So we're writing custom software for our Raspberry Pis. Our theatrical consoles are black boxes, right? It is sensible for us to write our software to put the burden of this translation into a Raspberry Pi somewhere. And so for precedent, let's just go to Google. And I'm writing in Node.js. So if I just Google Node MIDI, I get a package called Node MIDI. Great, right? This seems to be our missing link. So now we just need a USB to MIDI interface. And we can send and receive MIDI messages through a Node process, right? We've got now a running web server that is talking to multiple devices around the room via WebSockets. And within that web server, Node is highly event-based. Our Node MIDI module emits events when MIDI messages come in, and we can emit events that send MIDI messages back out. So it seems to be mostly solved, but there's still one hitch, which is that this is a standard MIDI message. It's 3 bytes, has a status, and data 1, data 2. Usually this is essentially a command. You're turning a note on, turning a note off, which note you're talking to, and a velocity with which you want to start. Basically volume, right? But we are not using vanilla plain old MIDI. We are using MIDI show control. Show control is an extension of MIDI that uses many more bytes to construct significantly more complex messages. This is what a standard MIDI show control message looks like. This is an array of bytes sort of laid out to be a little more readable, but basically says, first byte says this is a system extension. This is the particular extension, MIDI show control, which device ID, a delimiter, what type of command, which specific command, which queue to send, another delimiter, where to find that queue, another delimiter, where to find that list, and so on. So the good news is that our node MIDI module can handle these messages. We can write these messages manually. Of course, this is not a developer-friendly way of working, right? So our last step is simply to write a function, in our case, extend this module, to translate between the two message formats, where we have an array of byte values that we instead turn into an options hash and can go back and forth. This is trivially simple, right? This is, you all know how to do this. This is something you've done, I'm sure, similarly in a project of yours. So what we've done now is, before we've written any code, we have identified our core engineering challenge, which is going to pay dividends across our stack, right? Through smart research and smart framing of the problem, we have reduced this to a trivially simple task of simply translating a byte array into a JavaScript object and back. This is before we've done any implementation. So if we go back to our master list, we now have everything we need to build out a coherent framework for inter-process communication, right? Solving this particular problem had the added benefit of isolating many of our remaining problems. So now our remaining problems, because we have built a cohesive framework for all of our nodes to talk to each other, our remaining problems are now primarily isolated to local scope. They're no longer problems of coordination. So at this point, we have a choice. We can either execute on the problem we just solved, meaning start writing code, or we can do more planning around the remaining problems and start to draft out what are the remaining issues to be solved to finish out our problem as a whole. Either one is fine. It will depend on your specific deadlines, project dependencies, whatever. You'll probably do some kind of mix of both, right? You'll probably identify a problem that needs to actually be solved before you can start planning a next one, and so on. I'm not going to debate waterfall versus agile methodologies here, other than to say this method can be used for either one. I'm going to take a moment and wet my whistle. So, a few tips on framing your problems. Begun with a short parable. My grandfather had an electrical contracting business. And he told me, which when I was like 11 years old, I thought this was the cleverest thing ever. He told me about when he was hiring a new electrician, he would always ask them, he would pose a problem to them. This is sort of like the original coding interview, right? He would say, you have an atrium, a 3-story atrium, and a light at the top. And you want someone to be able to switch on that light from any floor in the atrium. How do you do it? Of course, the answer is simply to drop a string down the center of the atrium, right? I thought this was hilarious and so clever of my grandfather. But your pro tip is to know the problem that you're solving. If all you need to do is make sure that someone can turn on that light, right? Don't dive in and start working with, 3-way switches. This would be diving in. What problem are you really solving? You don't want to be blinded by your expertise or your love of solving problems, right? We're engineers. We love to solve problems. We get excited about writing code. But doing so will often blind you to the fact that you may not actually have to solve as many problems as you think you do. The professional is personally removed from the solution and takes some time to consider. So for an example, in our project, in The Last Defender, this was the patch bay, right? The patch bay that you would use to disarm ICBM missiles. You're trying to avert nuclear disaster by taking 2 cables, plugging them into 2 jacks, pressing a button over here, and if you got the 2 jacks correct, it would disarm a missile. So initially, I looked at this, and I'm thinking, I have to detect arbitrary insertions into 260 different jacks, right? And I'm thinking, how am I going to do this? I'm planning to do that. You know, this is a theater company. We have a very low budget. I'm trying to figure out how I can do this on a single Raspberry Pi. And of course, we don't need to determine insertions into any arbitrary set of jacks. We need to determine insertion into 10 predefined pairs. So instead of wiring up every one of these were 1/4-inch audio jacks, right? Instead of wiring up every one of them, we wired up 10 circuits that would be completed when the jacks were inserted into each receptacle, right? Excuse me, the plugs inserted into the jacks is where I was going with that. So this takes our complexity down from 260 circuits that we thought we had to wire at first, plus 1 for the button, to 10 circuits. So make sure you're aware of your assumptions. Pro tip number 2 is to talk to people, right? As I said earlier, people have done this before you. No matter what you think you're doing, people have done it before. So I'm a software engineer. I am not an electrical engineer. I was sort of finding my way blindly with you know, a dim flashlight and hand-sketched map through a lot of this project. So when we reached the portion of the AI, or I call it the AI. We referred to it as the AI in the game. It was not actually an AI, but it was a supposedly mad AI hell-bent on world destruction. But the self-destruct interface, right, where every player had to insert their cards into the computer. What we wanted was for each card insertion, the light would turn from red to green, and we needed to also be aware that all 16 cards were inserted, right? And I wanted to make sure that all of the that we were not faking that it was truly a one-to-one. Oh my gosh, sorry. I wanted to make sure that we weren't faking that. That when all 16 cards were inserted, we were actually detecting that. So I'm trying to come up with, you know, one single circuit that is going to do all of these things, so that I could rely on a single switch and be independent. Each slot would be independently controlled in the light, but also I could rely on knowing that each switch had in fact been tripped. And so I'm sketching all of this out based on what I know of, you know, transistors and diodes, and trying to come up with something to work. And I talked to my brother-in-law, who is actually an electrical engineer at Apple, and he looks at me and he's like, you know, they make these switches. They're called dual pull, dual throw, which is 2 switches on 1 lever. And you can just have 2 separate circuits, one that runs all the way through all 16 slots, and a circuit for each one for the lights, and divide it all up. So now you can do that with, you know, 2 circuits is fine. But you can rely on the actual hardware of the each switch being actuated one time. So in talking to someone who had done this before, who was in fact an expert in this space, he gave me something that was trivially simple to him. Like, he wouldn't have even thought about it. But to me was this golden nugget of amazing knowledge that solved my problem. That you don't know what you don't know. No matter what, like, no matter where you are, no matter how advanced you are in your field, You often don't know what you don't know, especially if you are up against the edges of your capabilities. So find the person who does the odd thing as their normal thing, and talk to them. Find out what they know. So the next time you're up against an ambitious goal, before you push back, before you go tally-ho, seek out your patterns, seek out your precedent, and talk to people. And by framing your problems correctly, you can avoid unnecessary work. So again, my name is Ben Wilhelm. You can find me at nimblemoose.com. If you want to play The Last Defender, we are bringing it back sometime this summer, most likely. Go to thehousetheater.com or follow @thehousetheater on Twitter. And I'm probably allowed to tell you that there will be a second escape room that we are building alongside of it. So if that's exciting to you, go there too. So thanks. Thanks. I'm happy to answer any questions or adjourn to eat pizza. Great. Yeah.
How did, I don't know how you picked Node for the coding language. How did that work out in the
How did I pick it, or how well did it work out? I picked it simply because it was the language that I was working with most at the time. So I was very familiar with it. I knew that I could sit down and write what I needed to, like, when you have an idea, basically I found myself going tally-ho with Node and had to like, and so I knew that I wouldn't have to spend a lot of effort getting up to speed on some other language that maybe I was less familiar with, but may on paper look more appropriate, but we had a very hard deadline. Like this is, like theatrical productions are the original waterfall project. Like you have a hard deadline of opening night and it doesn't move. And so you want to make sure that you're also optimizing for who you're working with and the talent you have on your team. And also, like Node is event-based, so like it was a great fit for this particular setup. So, anything else? All right. Well, thank you.
Thank you all for coming tonight. Give one more round of applause for coming in.
Thanks.